So here's the thing. You want to know about that negative sign, I'd imagine? Right?
Yeah.
Like what's going on with that negative? So what do you do with that negative?
Distribute it.
Distribute it in. So the way you could write this is one chain first. A to the fourth minus 2a plus 7 plus 3/10 a to the fourth minus 6a cubed minus 2a. We're distributing that again. Plus 7. 2a to the second. Thank you. That's a typo. Thank you very much. Okay. So it's 2a to the second. So this is how I would do it. And then I would, what I like to do personally is I circle the things that have the same power. You have here and you have here. So what do you have? You have 2/5 plus 3/10 a to the fourths. Then what am I going to do? What next power? What power should I do next? Cube. Are there any other ones? Minus 6a cubed. Next, what do I do? Look for squares. Any squares? Yep. Minus 2a squared. And then I'm back to a right there. Are there any other a's? And then I have the last term. 7 and 7 is 14. So what's the only thing you have to do here to finish this? Simplify that fraction. So how many tenths is 2/5? That's 4/10. So you have 7 over 10. And I really would like it if you put parentheses around like this. I would really like it if you did this, because this right here is totally unambiguous. There's a final answer for you right there. Now, what was that other method that I showed you in the video last night? Yeah, vertically. That's actually going to be really helpful if you have a lot of terms. It's super helpful because it really helps to not miss something. Like literally, I will do this and then I'll start checking things off, but then did I check it off again? You know, sometimes I get confused. So you could do it in vertical form where you literally have 2/5 a to the fourth. You'd have minus 2a and plus 7. Why did I put that space there? Yeah. There's nothing in those other power. A to the fourth minus 6a cubed, right? And then you have minus 2a squared and plus 7, right? Because I distribute. So what do I have now? I have these columns, right?
I did it where I put all the same ones in the same row.
That's fine. You can do it in rows and then do each row separately. That's totally fine. This is kind of cool because it allows you just to see, just line it up. There's however you want to do it is fine. Eventually you won't have to do it out, but if you have a whole lot of terms to keep track of, do something. Do something. Here, 67, find a model for the total amount spent, A, in billions of dollars spent on natural gas and electricity. So for this one, what are they essentially just asking you to do? What do you mean combine? Be more specific. Without using the word combine. Add them together. So which ones are you adding? So you're doing N plus E. And that equals what? So you know that A equals N plus E. So you have some like terms here. You can use your calculator for the decimals, right? So you're adding this term and that term. Then we have, are these in standard form? Yeah, they're nicely written in standard form. Descending order of powers. So you added them together. That's great. And they actually gave you the graph, which is good. According to the models, will more money be spent on natural gas or electricity in 2020? How do you figure that out? Yes. What does T equal first? Not since 1989. So what is 2020? 31 years. So T equals 31. So what are you doing with T equals 31? Into which equation? So look, according to the models, will more money be spent on natural gas or electricity? So you're doing N evaluated at 31 and what? And E evaluated at. So you're plugging 31 into both N and E. Now, do you really need a calculator to do that? You don't have to, but you want to do it in less than an hour, right? I mean, to plug 31 into these equations, what would you have to do? You have to square 31 and multiply it by 0.107. Does that sound like fun? No. Say no. So you'd use your calculator. Great. Okay. So then for 69, it says the graph at the right shows U.S. energy spending starting in 1989. Models N, E, and A are shown. Copy the graph and label the models N, E, and A. So which one is A? Which one's A? Yeah, this is A. Why? Why do you know A is the upper one? Yeah, it's the large. They're combining them together, right? You're combining them together. So which one is E?
The red one.
The red one. And which one is N? The blue one. Interesting. So what do you also notice about the paths here? This is just a side question. If you had to compare E and N, what do you notice about them? It's going at what? Yeah, what type of path is that? Linear. This looks like it's linear. Now, is E actually linear? Not quite. It's kind of linear. It's not really. It looks linear because we at the scale, but do you know if it's linear or not? You can tell for certain because you have an equation for E. Yeah, is E a line? Is this a linear polynomial? How do you know it's not? Yeah, t squared equals a quadratic. And this was something that was important for you to remember. So on these two right here, how many terms are in each? N and E. How many terms are in it? There's 3 in each one. So what would each of them be called in terms of the number of terms? They're both trinomials. And they're both what in terms of degree? What's the degree of each? Degree is a number. These are both quadratic trinomials. Quadratic has to do with the degree, and this has to do with the number of terms. The number of terms. How many terms are in each? 3, trinomial. Then there's 4, 5, 6. There are words that continue in this vein.